The first thing we should know for the revision of IUPAC, right, is understanding what is different representation of representation of organic compounds. Okay, so I'll put with an example. Suppose I have carbon, right, having 5 carbons here, and hydrogen, which is 12. Okay, but here we don't know how these carbons are present. This is simply representation is called as, okay, uh, molecular formula. This is called a molecular formula. This does not give anything about the structure, but if you want to know the structure of that molecular formula can be written in multiple ways. One is condensed form. Condensed form. Suppose if I put the condensed form like this, C, then CH3 4 times. This is called the condensed form. Okay. In fact, here, since we are writing about the information on how the number of hydrogens are present, okay, how many number of hydrogens are, how the how many number of carbon and hydrogens are present, that is called as condensed form. Now, the same can also be written as semi-condensed form, semi-condensed form, okay, which is carbon representing with the bonds also. Between carbon, what type of bonds it is. Rest of the group is same. This one is called semi-condensed form. Then we have bond line form. Then we have bond line form. Okay. Bond line form is only showing with lines, and the edges, the ends, sorry, not edges, the ends as well as the intersections are always called as are always termed as carbons. So therefore, this molecule will be like this. This is the bond line structure of this particular molecule. Got it? Now, last thing is expanded form or skeleton. Skeleton form or an expanded form. Expanded form is writing out all the bonds possible. Whichever bonds are present on it, you show all the bonds on it. So this is how you will write down all the hydrogens, and we call it as the expanded form. Okay, clear beta? So I hope you do understand what is condensed, semi-condensed, bond line, and expanded form. Got it? Right. Now, suppose this is only carbons. What if you have nitrogens, oxygen, sulfur? These are all the elements which are present in it. Then how do we represent? So notice this condensed form, how I am writing for certain groups. H2N, and then I have CH2 twice. Suppose if I keep it like this, and OCH3. This is how I have written. So, well, if at all I have to write the semi-condensed form, I would write it like this, H2, and then there are two back-to-back carbons, so like this. Then there is oxygen, then there is CH3. This is semi-condensed form. Okay, clear? How do we write the bond line form in that case? Now, this is the question JE has asked. Last year JE question, important. JE question on bond line. Got it? So remember, you better, whenever I write this way, JE question, so this is a part you have to revise a lot. Okay. So the same thing how it is being written is like this. N2H, one line here like this. That means it represents two carbons. Then we have oxygen, then we have methyl. Have you noticed the liberty of writing hydrogens and carbon into lines is, I mean, the liberty of writing everything into lines is only for carbon and hydrogen. not for oxygen, nitrogen, and other heteroatomic species. Is this logic clear, beta? Now, what is J asked is this one. Okay, write the bond line, form of, okay, carbon, um, carbon having CH2, sorry, carbon having CH2CN, carbon having CH2CN twice, like this, with a double bond carbon having CH2CN twice. Okay, so this is the question that has been asked. So tell me, how do we write the bond line structure? So first you need to understand there is one carbon जिसके ऊपर दो two other groups are present, which is CH2CN. So first I will write the semi-condensed form, carbon double bonded carbon. Okay. By the way, if it is a semi-condensed form, I do not have to represent this double bond also. Then also you should be able to understand कि इनके बीच में double bond है. So then you have two bonds connected with CH2CN, CH2CN. Here also CnCH2, CnCH2. That's how it is connected. Now, girls, how do we write the bond line structure, bacha? So you can see one we have here. First, wherever there is a carbon, the cyanide group is a functional group. That is like a heterospecies. That you cannot write it in a dot or line. So you start writing the line form here. So 1, 2, 3, 4, 5. So far it is clear. Then there is a double bond. Thereafter, here we have a cyanide, 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 and cyanide. Done. This is the bond line structure. Did you get that? So this is first topic that you need to understand. Okay, I am hoping that there should not be any problem in finding out or writing out bond line structure, or given bond line structure, write the condensed form, semi condensed form. ये सब हो जाना चाहिए. Okay, this is concept 1. Second concept. Second concept is about identifying homologous series. Homologous series. Correct. If a particular functional part is present, and that is only continuing, correct, and that is only continuing, and only it is varying by CH2 formula, the differential part is only with CH2 formula, then it is called as homologous series. For instance, example, CH4, the homologous series, if at all I write, that is CH3, CH3. Then CH3, CH2, CH3. These are all in series. These are all in homologous series. The variation should be only with CH2. Even if you have a functional group also, let's say I took propanol, and if at all I write this as isopropanol also, this is also homologous series because there is one extra CH2. So it doesn't have to be straight chain. Even like this also, this is also an homologous series. So if at all I say A, B, C, AB is homologous, okay, AC is homologous series, but BC is not a homologous series. I think this part makes sense. Any doubt here? So I'm sure you must be aware of this homologous series before also. So there should not be much problem with this part. Clear? Done, right? How to write the homologous series here. Right. Okay. So whether it is alcohol or anything, you just have to keep increasing the number of carbons. Suppose if the question is asked, what is the first member of the homologous series? first member of homologous series. Correct? First, for alkanes, what is it, beta? For alkanes, the first member is CH4. Alkenes, who is the first member? CH2, CH2. This is the first member. Same is the case with alkyne. Suppose if it is for halides, one carbon is enough to represent the halides. So CH3X. So that will be the first member. For acids, who will be the first member? HCOOH. For ester, very important. See, for esters, who is the first homologous series? HCOOCH3. Got it? Please remember how it is. Okay, for alcohol, who is the first member of the series? CH3OH. This is the first member of the series. बस यहाँ से आप एक एक कार्बन बढ़ाते जाओ. So then you will get the representation. I mean, then you will get to know how to write the homologous series. Okay, clear that? Clear with that, right? Very good.
Yes,
Okay,
sir.
next. Next part. This is part 2 that you need to learn. Again, there is a direct JEE mains question from here. You should not get confused. More practice you do from PYQs, you will get an idea, okay, how to solve this. Next, the third one. Okay, the third point is about classification. Classification of carbons. Classification of carbons. Okay, carbons are of many types. Now notice this. Suppose if you have it like this, the end carbons are always called as 1 degree. The rest of them are 2 degree and the end carbon is again 1 degree. So then suppose if at all I have a structure like this, double bond here, triple bond here like this. Okay. Now still if you notice this is 1 degree, 1 degree, only 1 degrees. 2 degree, 2 degree, 2 degree, 2 degree, 2 degree and 2 degree. And these three are 3 degrees and here also it is 2 degree. Done. Clear? So this is the first classification. You should know what is going to be 1 degree and 2 degree. And it is usually asked how many number of 1 degree, 2 degree are present. Got it? I think that should not be a problem. I'm sure you guys can do that. The problem comes with the second classification. The second classification is about using these terms. What is vinyl, allyl, phenyl, benzyl, okay, and propargyl, okay. What are these terms now? See, very simple. If you have any simple double bond position, wherever the double bond thing is continued like this, then the double bonded carbon both are called as vinylic carbons. Vinylic carbons. Correct? Got it? That's why if you have an example CH2 double bond CHCl, we call it as vinyl chloride. We call it as vinyl chloride. Done. Similarly, the double bonded carbon, the sp3 carbon which is directly connected to a double bond, this should be sp3 first. That is the important part. This is also sp3. So if it is sp3 carbon connected just to the double bond, that is called as allyl. So these two are allyl compounds. This position and this position, these two are called allyl carbons. Okay, and the hydrogens present on it will automatically become allyl hydrogens. Got it? Clear on that, right?
Yes,
Okay.
sir.
Next, if you have benzene and every carbon on benzene is called as phenylic position. So this is phenylic carbon. This is phenylic carbon. Similarly, if you have benzene, after that there are certain groups like this. Okay, imagine I have groups here this way. Okay, now notice something very interesting in this case. I have double bond here like this. Okay. Now notice carefully, everything that is present on only. So this is phenyl. Okay, everything. So how phenyl carbons? Make sense? So phenylic carbons, six phenylic carbons. Next, the sp3 carbon, which is immediately connected to phenyl, that is called as benzyl. So you can see this is benzyl. Is there anything similar to benzyl? Is there one more benzyl? Yes, this is also benzyl. It is sp3 carbon. So that is benzyl. But this is not benzyl. Why? It is sp2 carbon. If it is sp2 carbon, automatically it will qualify for vinylic. So that means this is vinylic carbon. And this carbon here, the last ones which I'm marking here, these two would automatically become allyl. So this is allyl carbon. And obviously the double bonded carbons wherever you had here, you can see this double bonded carbons here as well as here. So what will that become? That will become vinyl. That will automatically become vinyl. Now have you noticed something? This carbon is allyl also and phenyl, benzyl also. This is allyl as well as benzyl. If both are coming, then priority should be given to benzyl. Correct? So priority wise, benzyl is more than allyl form. Correct? Now let me put all of them together here. There are six phenyl carbons. There are two benzyl carbons, and there are four vinyl carbons, and there are how many allyl here? You can see two allyl here. So two allyl carbons. Acha, sorry, here also there is uh, vinylic group. So two vinylic again. So total six. Six phenyl here and two allyl carbons here. Done. So this classification is also clear, beta. Any doubt here? Both of you? Very good. See the next classification. The next classification is based upon the wording that need to be used. Iso, tert, neo. When do we use this part? Got it? Okay. Suppose if you have butane like this. Okay. So in butane, if there is any extra methyl group coming on top of it like this, correct? Then this group will be called as isoposition. Okay. In short, how do we put isoposition? Let me explain it from the start. Suppose I have straight chain here. This is connected to some functional group like this. So what do we call? We call this as N-propyl substitute. N-propyl substitute, because there are three carbons. Suppose if there is a main chain here, and on that carbons here, this methyl is been taken and put it to this position, then it will become, now this will be read as, iso. Now this will become isopropyl. Okay. Similarly, if you have like this, 1, 2, 3, 4. So if you have 1, 2, 3, 4, 4 carbons, so this will become N-butyl. This is an N-butyl substitute. While if you have the same butyl, but one position I have changed it here. So then that will become isobutyl. Correct? So this is isobutyl group. Got it? You can keep on doing it. Iso means you have to keep on pushing it till you get that. Okay. So in short, if you have it like this, if you have groups like uh, isobutane. Isobutane means this is the group. Okay, this one is isobutane, correct? This is isobutane. And if you have like this is isopentane. As a complete molecule also we can call it as isopentane. Got it? Similarly, one group that is important where you have to show it as the isoform. See, rest all will be like this only. 5 and here. So this will become isohexane. This is isohexane and so on. Okay. But when it comes to isooctane, it is not like that. Correct? When it comes to isooctane, first you have to write a 5-membered chain here. 1, 2, 3, 4, 5. Then on this second position, we should have 2 methyl. And on the last position, we should have 1 methyl. So then this will become isooctane. The questions on isooctane are very important. That means directly you will be asked, write the structure of isooctane, write the types of carbons present on isooctane, how many number of alpha hydrogens are present, how many number of alpha, sorry, how many number of 1-degree hydrogens, 2-degree hydrogens are present here, like that. So let us discuss that part on this question on isooctane. How many primary, secondary do we have here? Check it out. For this compound, right, you can see we have, this is 1 degree, 1 degree, 1 degree, 1 degree, and 1 degree. So total 5 1 degree carbons we have, and one 3 degree, one 2 degree, and one 4 degree carbon also is there. Got it? So how many primary we have? 5. So 1 degree we have 5 carbons. 2 degree we have 1 carbon. 3 degree we have 1 carbon. 4 degree we have 1 carbon. Done? 4 degree is called quaternary. Okay? Clear? Question could be asked like this also. 1 degree is also termed as methyls. So how many methyls we have? Because these are all the methyl groups we have. So these are methyl groups. So methyl groups are there means how many? 5 methyl groups. If you have 2 degree, it's 2 degree CH2. CH2 is called methylene. So one methylene group is there. Okay. 3 degree. If it comes to 3 degree, it is called methine. INE. Ine. 4 degree does not, because 4 degree does not have any hydrogen at all. So we cannot have that name. Clear? Isooctane is clear. Very important. Okay. Right. So you should know how to represent iso, neo, iso. What do you say? Then, so far I have discussed only iso. Let me tell you about tert and all of that. Check it out. If carbon has, this is a main chain, correct? And if this carbon immediately has 3 carbons connected to it, then this will become tert. This is called tert butyl. This is called tert butyl group. Okay. So tert butane or tert butyl group is connected. Okay. Similarly, if you have like this 5 carbons also, like this, I have 1, 2, you can see 1, 2, 3, 4, clear, and 5 here like this. So that means this is now tert tert pentyl. This is tert pentyl. And similarly, if you have, only group given like this, then this is called neopentane. Neopentane. This is simply called neopentane. Carbon having quaternary position is called neopentane. 5 carbons are there. Okay. So if it is connected directly to the main chain like this, okay, like here, if you have noticed here what I have written, instead of using this 1, 2, 3, 4, 5 carbon as a tert, we will use this as a neo, not tert, sorry, neo. So neopentyl group, correct? Tert is like this. Suppose it is directly connected, but this is how the group is. So now it is tert pentyl. pentyl. Okay, so these are the words used for tertiary and neo. Okay, clear beta? Right. Next is understanding. This is concept number 3. Concept number 4 is understanding DOU, degree of unsaturation. Degree of unsaturation has multiple names. DBE, double bond equivalent. Okay, double bond equivalent, or uh, index of hydrogen deficiency, IHD. DOU means what? Degree of unsaturation. DB means what? Degree, double bond equivalent, or IHD means index of hydrogen deficiency. All of them meant the same thing. Okay, so sometimes it is simply written as DU, degree of unsaturation. Instead of DOU, it might be written as DU also. See, my suggestion is there are two formulas. You can use one formula to be more easier way, correct? So you can see, how do we calculate? DOU is equal to how many number of carbons you have, just add one carbon to, add one number to it. Then subtract minus number of hydrogens plus number of halogens minus number of nitrogens. This whole divided by 2. This is what you should use. Okay. This is formula 1. Or the other way of writing it is, basically you are just extending it. You can write this as 2 into number of carbons plus 2 by taking LCM plus number of nitrogens minus number of hydrogens minus number of halogens overall by 2. That's it. So it is one and the same. Okay. Clear. Is this part clear, beta? So if a formula, okay, is given and DOU need to be found. So how do we found? DOU need to be found. How do we check this out? Benzene is C6H6. Suppose if you have C4H6, okay. Suppose I have C7H5, correct, and N here. Sorry, H9. I have H9N here, like this. H9N, correct. Then notice what is the DOU in all of these cases. So first we'll write it as 7 minus 6 by 2, 5 minus 6 by 2, 8 minus 9 plus 1 by 2, correct? 8 minus 9 plus 1, right? So it is like this, minus 9 and plus 1, sorry, minus 1 by 2. Okay, because in bracket when it is minus, that will automatically become plus. All right, so you can see how much we are getting here. So 7 minus 3, 4, 5 minus 3, 2, 5 minus 3, 2. Okay, just a second, take this call. Right, check it out. So 4 here, 2 here, and how much we are getting? 9 minus 1, 8, 8 by 2, 4. So another 4 here. Got it? Right. So this way you can figure out. Now notice this one. Whenever I have degree of unsaturation as 1, DOU as 1 can be written, 1 can be converted as a double bond, okay, or it can be written as cycle, 1 cyclic. Clear? If we have 2, I can make again so many things here. I can make a double bond, we can make a triple bond, we can make 1 cycle, okay, cycle plus double bond, or I can make two cycles like bicyclo type of group like this. Correct? This is called bicyclo group. Okay, clear beta? So while writing isomerism, this representation would be uh, easier to understand. Okay, clear? Right. Given any structure, just by checking out the structure also, we should be able to say it whether it is going to have how much degree of unsaturation. So let me check out this example. These are some famous important ones here like this. Suppose I have this one. This is called cubane. For cubane, if at all I have to find degree of unsaturation, basically you have to keep on breaking the bonds till the time it becomes straight chain. Till the time it becomes straight chain. Now notice carefully one, because I'll start breaking one after the other. This is first bond broken. Okay. Now I'm breaking the second bond also. Here the second bond is also broken like this. Okay, let me put that line here. Second bond also is broken. Okay, let me take this copy here. Next, I'll break one more bond here. So let me break this back bond here like this. Okay, third bond is also broken. Clear? And now, if you notice, now here fourth bond is also broken like this. Correct? And lastly, if I take this one, I'm making one more bond to break. 5 bonds. Done. Now notice, or let me break it on the, yeah, this side. Here. You can break it any side, doesn't matter, like this. Done. Check. Now, have you noticed this has become straight chain? 1, 2, 3, 4, 5, 6, 7 carbon with a methyl group on it. Done. Now it has become a straight chain. So how many number of bonds you break, that becomes its degree of unsaturation. Got it? So here it is 1, 2, 3, 4, 5. 5 times you have broken. So degree of unsaturation is 5. This is just by checking out the structure. So whenever you have any structure given, you just break down and see how much will be the number of, what will be the degree of unsaturation. Okay. If by chance there is a double bond also existing in it, then that also you have to count it. Let me show one example here. Suppose I have something of this sort. Okay. Double bonds alternatively like this, and yeah, this way. Suppose if it is present, clear, and one double bond here, yeah, that should be fine. Yeah, here one more double bond. See now. So for this compound, if at all I have to make breaking, you start breaking up the bonds and then see how much you will get it. Okay. So best thing to do is always break the outer ones first. Outer one circles, you break it down. So you can see now I'll do it simultaneously. 1, 2, maybe I'll break it here. 3 and 4, and maybe somewhere here. 5. Okay. So can you notice that outside everything has become open chain now? 5. And now inside the only one which is left, that also you break it down. So here, somewhere here I broke it. You can see here I broke, 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 and here I broke. So how many total? 6 bonds. 6 bonds I broke. So for breaking and making into straight chain, degree of unsaturation now will be equal to 6 plus, now count the number of pi bonds. So 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 9. So what is the degree of unsaturation? 15. Got it? I hope this part is also clear. Okay?
Yes, sir.
Correct. Next. See, in simple terms, whenever you use the word saturated and unsaturated, saturated means that it will always have straight chains, correct? And Maybe you can notice this one also. Benzene is also a saturated form, although it has a double bonds, because those double bonds are not isolated. It is not like these double bonds are separated out. It is like a ring only. So that ring is not directly reactive for hydrogens. Okay. That's why this is also called as saturation. But in generally, alkanes are always saturated. Very generic form, if you notice, alkanes are the saturated forms. Got it? Next. The next term you need to understand, fifth one, is about cyclic nature, cyclic forms. When you have cyclic forms, what do we call it? Okay. Within cyclic, we have two kinds, beta, homocyclic and heterocyclic. Okay. First, let me start with homocyclic. Homocyclic means all carbons only, all carbons only making cyclic structure. So we should have only carbons making the cyclic structure. Okay. Within that, we have first alicyclic. Alicyclic. Alicyclic means simple carbon, structures like this. This one, this one, this one. These are all alicyclic. Got it? Second one is aromatic. Aromatic, like benzene, like this. These are all aromatic. Okay. Within aromatic, we also have, types again. These are called benzenoids. Okay. In aromatic also we have types, benzenoid and non-benzenoid. So we can see within that we have benzenoids, benzenoids, benzenoids. Okay. Benzenoid means anything which has a benzene ring in it, like this. This is naphthalene. Third one is anthracene. This one is anthracene. Correct? Naphthalene, anthracene, phenanthrene. Next one, if you notice, this is phenanthrene. These are all benzenoid forms. Next, we have non-benzenoid forms. Non-benzenoid forms. Non-benzenoid forms like this. We have some fused ring like this. Got it? And here, sorry, my mistake. On this side, I have a double bond here. Clear? And somewhere here, I have a five-membered ring like this. Got it? And I have another two double bonds here like this. This is called azulene. Got it? The compound is aromatic. Okay. But it is not benzene type of form like this. Double bond O. This is called tropolone. Again, aromatic. Clear? So these kind of compounds are called non-benzenoid forms. Clear? Homocyclic is clear, right? Similarly, we have heterocyclic. Heterocyclic. Heterocyclic also has alicyclic and aromatic. Here, if you have alicyclic, which means it is a cycle made up of, you know, carbon as well as nitrogen, oxygen, and other elements also present in it. So this kind of alicyclic, heterocyclic, which are alicyclic. Next are aromatic. Heterocyclic, but also aromatic, like this. This is called pyrrole. Then we have pyridine, correct? Then we have furan. This is called furan. This is called thiophene. These are all aromatic. Okay, clear, beta? There is nothing like benzenoid or non-benzenoid form here. Only two distinctions here. So homocyclic cases are clear, beta. So I don't think there should be any complexity here. Correct? Next, functional groups. I'm sure you are aware of what are the functional groups, but just I will repeat a basic terminology again. So most importantly, we should know the order, like what should be the order of functional groups, which order should be taken I mean, which should be the highest order that is considered whenever you have functional groups. All right. So one second. So functional groups and their names. You know that whenever there is a functional group, it will have two names. One is called prefix name. The other one is their suffix name. Okay. So what is that we will use it as a prefix name and what is that we will use it as a suffix name? This is the first thing we should know. Okay. Just a second. First, what you need to know is what is the class of organic compounds, what is the functional group, what is the secondary suffix on it. So you can notice that alcohol, OH, secondary suffix is O, all. Aldehydes, aldehydes is CHO, al, ketone, C double bond O, on. Carboxylic acid, COOH, oic acid. Esters, COOR, alkyl with an ending with O8. Acid chlorides, OL chloride. Amides, only amide. Nitriles, nitrile. Amines, amine. Okay, these are the main functional groups and their respective suffix. Now notice the order in which the priority is being given. The priority is always first to acids, COOH. Then comes alkoxy group, correct? Then comes acid chloride, amides, cyanides, Now this is not a priority group. After that we have ketones, aldehydes, then ketones, alcohols, then thioalcohols, then imines, and nitro and halo does not have any priority at all. Correct? So that is the priority order. Clear, beta? So let me just put down the priority order again. Priority order wise, if you notice, so acids will be the first, then comes sulfonic acid, correct? By chance, if sulfonic acid is given, then comes esters, right? So then comes anhydrides first and then esters. First anhydrides, and then comes esters. Then we have acid chlorides, amides, nitriles, then aldehydes, then ketones, right? Alcohols, thioalcohols, and amines. Within double bond and triple bond, if you notice, double bond is given more priority than triple bond. And within double bond, if you have a phenyl group, then phenyl is given more priority than this one. Got it? So typically, this is the order of the functional groups. This is something which you need to remember. At the same time, what are their suffix name is something which you need to know. Now, what is their prefix name? Now I'm writing only the prefix name. You can see carboxy, alkoxycarbonyl, chlorocarbonyl, carbamoyl, okay, cyno, alkoxy, halo. Ketone can be written as both oxy or keto. CHO can be written as formyl, then hydroxy, mercapto, amino, imino, and nitro. These are the terminologies that you should know. Got it? Right. Okay. Now, since you got an idea about how the functional groups are, what are all the functional groups? Now, based on that functional group, we should be able to figure out what is the name of the compound. Okay. Usually, common name is important, but at least whatever the ones which are most important, only that part we will, study. Now, let us write the IUPAC names of the most common ones first. Okay. This you should practice along with me. All right. So, because by writing IUPAC only, we will be learning out all the rules. Got it? We don't have to learn it as a separate rule again. Clear? So, check out starting with first one. If you have CH triple bond CH, then what do we call it? So, we have two things. One is IUPAC name, the other one is common name. Got it? IUPAC name is ethine and common name is acetylene. Common name is acetylene. Got it? Similarly, if by chance I have CH3, CH2, C triple bond CH, then this is called as but 1-ine or simply butyne. We can use it as but 1-ine or simply butyne. Common name is it is like an ethyl substituted on acetylene. So this will become ethyl acetylene. Got it? This part I hope you understood. Correct. Same way, if by chance there is an alkene here, like this, I have a double bond here. So in that case, you will go for the lowest numbering. Now you notice from here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The number is same from both the ends. So you should always give priority with the lowest numbering on the double bond. So here if I write it as 1, 2, 3, 4, 5, 6. Double bond is falling between 3 and 4. So lower number is 3. So that's what you will write. So hex 3-ene. This is the name. Next. If by chance I have double bond also and triple bond also at the same position, in that case priority should be given to double bond. So number should start from here. 1, 2, 3, 4, 5, 6. So now notice the naming here. Hex, we have, first what do we have? Lowest numbering is the one which you will write first here. So therefore we have hex 1-ene. See, notice this carefully. 1-ene plus I have 5-ine, correct? 1-ene and 5-ine. So whenever you remember this, whenever you come across an ene and the next term which is starting is with y or which one, A, E, I, O, Y. Just like I, O, U, here we have I, O, Y. Vowel sounding. If they are vowel sounding alphabets, then you have to remove this E. Okay, beta? You should always remove this E. So now, what should be the name? Hex 1N 5-ine. Okay, so this is the name. Now notice, suppose the same compound is like this. Double bond is here, now triple bond is here. Now notice, the priority should always be for the lowest locants first. If I go like this, 1, 2, 3, 4, 5, 6, I am getting double bond at 2 position and triple bond at 5 position. But if I go this way, 1, 2, 3, 4, 5, 6, I am getting triple bond at 1 position and double bond at 4th position. So if you notice the locants, the 1 and 4 locants are smaller. So you should go it in this way. 1, 2, 3, 4, 5, 6. Remember, double bond is prioritized over triple bond only when uh, both the sides, the chain have same kind of numbering. Correct? Then only we will give double bond as more priority. And now notice what should be the name. Again, it is in a similar way, hex, but this time, what is the group we have here? 4th position I have ene, and 1 position I have ine. So this is what you will write. Okay, clear? 4N, 1-ine. Clear? This is identifying how the double bond to be written. Now, the next type is the next thing is always about, PCC, finding PCC. Sorry, finding PCC. Correct? What is PCC? Parent carbon chain. So we are trying to find out what is the parent carbon chain. Got it? So wherever there is a group given like this, double bond is here, double bond is here, like this. So you should always find whatever be the longest chain which covers maximum number of double bonds and triple bonds. Longest chain which covers maximum number of double bonds and triple bonds. Just keep that in mind. So you can see 1, 2, 3, 4, 5, 6. This covers both the double bonds. If I go this way, 1, 2, 3, 4, 5, 6, even if I put 7 also, that will not become a straight chain, a main chain or PCC. So now, how does the PCC go here? Now, notice from here, 1, 2, 3, 4, 5, 6. From here also it is 1, 2, 3, 4, 5, 6. Here it is isopropyl and here it is N-propyl. Okay. Now check out alphabetically which one is better. Iso and propyl. I comes first. So that's why this should be more preferred. So what should be right from here? 1. So numbering wise, it should be 1, 2, 3, 4, 5, 6. Got it? Clear it up. So this is about PCC. How to write the IUPAC? We'll come to that. First question is about identifying the PCC here. Okay. Clear it up. Next, if you have like this, in that case, cyclic chain is also three membered, outside also three membered. If both the straight chain and cyclic chain have same number of carbons with alkyl group, everything should be alkane only, no alkene here. In that case, give priority to which one? Give priority to cyclic chain. But if by chance outside we have only two carbons but with a double bond, then the priority should be given to double bond. Done? Clear beta? Right. Similarly, if you have one ring like this, clear? Outside I have ring this way, correct? So again, priority should be given to 1, 2, 3, 4, 5, 6. But if you have rings like this, I have CH2, CH2, multiple rings here, right? In that case, priority should be given to only straight chain. Okay. And this starts with cyclopropyl, P. This will start with butyl. So butyl is given more priority alphabetically. So 1 and 2. Okay. Clear? Next. If you have a double bond here, correct? And a double bond here and a double bond here. Multiple double bonds are there, correct? And let's say here chain is extended a bit like this. Then you should notice for the double bonds, which maximum number of double bonds which are covered. See 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, or 1, 2, 3, 4. 1, 2, 3, 4. So the only way it is covering larger distance with more number of double bonds is this one. So, and here it is ethyl, here it is methyl. So who should be given more priority? Ethyl. So alphabetically, we should have 1, 2, 3, 4, 5. So this is the chain. Got it? Any doubt here? Okay. Now, most important question that comes here is about in cyclohexyl group. How do we put it? Now, I have first we will do with simple ones that include, you know, any groups which are halogens. Now, first we'll put all the halogen groups in this case. Okay. So starting with, see here, we have chlorine, bromine, iodine. Chlorine, bromine, iodine. Iodine, bromine, chlorine. Chlorine, iodine, bromine. Okay. And next one we have, got it? Suppose in this case we have chlorine, bromine, iodine. Next, this time I have chlorine with a double bond and bromine here. Chlorine with a double bond, bromine here. Chlorine with a double bond, bromine here. Got it? Like this I have. Okay. Next one we have chlorine and bromine. Chlorine and bromine with two double bonds. Okay. Chlorine and bromine with two double bonds like this. Chlorine and bromine with two double bonds like this. Chlorine and bromine with two double bonds like this. Done. Chalo. In all the cases, I would give you, you know, 5 minutes of time. Please make sure you write the numbering correctly. Now check one by one whether you got them right. See, I'll give you one statement reasons. First thing, whether you go right to left, left to right, clockwise or anti-clockwise, you'll get the same numbering. Because you get same numbering, alphabetical order or the precedence is being followed. So chlorine is more preferred compared to iodine. C versus I. Now here only lowest locant. 1, 2, 3, 4, 5, 6. This is the lowest locant. Lowest locant. Lowest locant. Okay. Again here numbering is same whether you go clockwise, whether you go anti-clockwise. In that case, alphabetical precedence is preferred. So 1, 2, 3, 4, 5, 6. First B, then C, then I. Okay. Next one. Always double bond is more preferred whenever there is a double bond. So 1, 2, 3, 4, 5, 6. Double bond here with lowest numbering of chlorine. So 1, 2, 3, 4, 5, 6. Double bond with lowest numbering of bromine. 1, 2, 3, 4, 5, 6. Again, whether you go double bond this way or this way, same numbering. So bromine is alphabetically more than chlorine. Next, here double bond is more preferred. Again, bromine alphabetically more preferred than chlorine. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Same thing. Bromine is more preferable, lowest locant. More preferable bromine compared to chlorine. So 1, 2, 3, 4. Check. Any doubt there? Any case, if you have a doubt, you can please do ask now. Got it? Pakka?
Yes, sir.
Right. Very good. Okay. Now, same thing we will put it with functional groups. What if you have a functional group there? Then functional group should also be given priority. Correct? And notice, once the functional group is given, functional group should be always given priority and try to make a chain which has the longest form with maximum number of double bonds and triple bonds. So let me show you a few examples here with functional groups. With functional groups, how do we need to write? Here. So suppose if you have like this with OH here and I have double bond here, correct? Now, first priority is not to double bond. First priority is always to functional group. You need to check out the lowest numbering on functional group. After that, the second priority is always towards the longest chain with having maximum number of double bonds. So that's the reason why the numbering will go like this. 1, 2, 3, 4, 5. This is the correct numbering. Clear, beta? Now from here onwards, we'll start writing the name also because the functional group has come into picture. Let us start writing the name as well. So how do we write? On third position, I have a butyl, correct? I have a butyl. And this is a 5 carbon. So therefore, sorry, 5 carbon. So it is a pent, correct? Pent. And after that, if you notice, we have at fourth position, we have ene. So 4 ene and 1 all, correct? And O is a vowel sounding letter or vowel sounding alphabet. So therefore that small e should not come into picture here. Correct? So this should be the name. Clear now? Similarly, if you have a double bond like this, I have OH and OH here this way. Correct? Now what do we prefer? In that case, let's say double bond is here like this. Okay? Now, first priority should be always about functional groups. If the double bond comes on it, well and good. If it is not coming on that double bond form, we can't help it. We just have to leave it the way it is. So therefore, now the numbering should go like this. Lowest numbering is always with the right hand. So therefore, you start from there. Now notice how do we name it? So what should be the name? The total carbon chain is 6, but on the fourth position, I have a propyl group 1, 2, 3. It is a propyl. So prop with internally, I will write this as 1, 2, 3 again. 1, 2, 3. This is internally within the chain. So on prop, we have one in. So one in. So since one is something which is default, you can simply write it as propene, propenyl. So 4 propenyl, and then this is hex, and we have 1 and 5, we have diol, correct? At 1 and 5 position, we have diol. So now notice this one. Whenever you have multiple number of functional group, then you write hexa. This A should be always come into picture. So a hexa, and then we have 1 comma 5 diol. Okay, 1 comma 5 diol. So hexane diol. Sorry, hexane. Here it is not double bonds present, so we'll write it as hexane. Hexane 1 5 diol. Hexane 1 complete E. You cannot miss out on that E. Why? You know the reason. I cannot miss out on that reason. A here, E here. Why? The next letter is D. D is not a vowel sounding letter. So therefore, this E should be present. So this is propene 4 propenyl hexene 1 5 hexane 1 5 diol. Got it? So I suppose this how to put it on the alcohol form, it is clear. Okay. Now let me put it on the uh, functional group, which is aldehyde or ketones. First, aldehydes. See, if you notice, aldehyde forms. So in the case of aldehydes, so we will always have at the ends here, correct? So now suppose if a double bond is here, so same logic here also. Start with numbering here 1, 2, 3, give the priority to the double bond. So what should be the name here? 2 ethyl prop propan al propan 1 al. Okay, propanal. Okay, similarly if we have an aldehyde, it will always be at the terminal end. So here also aldehyde, and here also if you have an aldehyde, I have 2 methyl here and 1 ethyl here. Okay, in fact with a double bond here like this. So priority should be the lowest numbering, and lowest numbering comes from left to right. You can see you have 1 at 2 position, we have 2 methyl groups. 3 4 4 position we have 1. So substitutes are 2 2 4. If I go this way, it will become 2 4 4. So this is wrong, this is right. So numbering should go like this: 1 2 3 4 5. Okay, so since this is the numbering, what should be the name here? On fourth position, we have ethynyl, ethynyl, and 2 comma 2 position we have dimethyl. We have dimethyl, and overall it is pentane. Complete N you have to write, and then 1 comma 5 dial. Okay, you have to write dial. You cannot miss out on that E. Remember that. You have to write the complete E. Pentane 1 5 dial. Clear with this part? Now, notice one important part about aldehyde is, what if the aldehyde is there on a you know cyclic structure like this? If it is on a cyclic structure, if it is on a cyclic structure, then what do we name it? Now, numbering should always start with the cycle which has on a cycle which has a aldehyde group on it. So 1, 2, 3, 4, 5, 6. This is the numbering. So we write it as cyclohexane, complete name, complete name. Then you will write it as carbox, carb. Sorry, first we write it as carb aldehyde. Only we write it as carb aldehyde. That's it. Got it. And this could be same with benzene also. So instead of that, I have benzene. I have CHO here. So what is the IUPAC name here? This is benzene carb aldehyde. This is the name. So here important part is you should be writing carb when aldehyde is not being part of the numbering. Okay, so this is carb aldehyde. So even if you have multiple number of CHO groups also, let's say I have CHO here, CHO here, and I have OH here like this. Okay, so you will start numbering where aldehyde comes with the lowest numbering form here. So you will start from here. So 1, 2, 3, 4, 5, 6. So this is the numbering. So now what is the name here? It is actually a benzene with a hydroxy group on it. So 4-hydroxy. This is the prefix name of OH. Then it is benzene, complete name. After that, I have 1, comma 3 dicarb aldehyde. Carb aldehyde. You cannot simply write it as dial. Here we have to write it as carb aldehyde. Okay. Any doubt? Same way, suppose if by chance I have an aldehyde group here, CHO here, CHO here, and another CHO here, like this. Now comes the problem. See, if I go from here to here, 1, 2, 3, 4, 5, 6. Have you noticed these 6 carbons? 2 carbons are covered for the uh, PCC, parent carbon chain, but this carbon is not covered for the PCC. If this type of situation comes, there is a new IUPAC name that was given starting with this number 1, 2, 3, 4, 5. So we do not include any one of them. You will only write the straight chain and you will simply write the IUPAC name this way. It is pentane having 1, 2, 4 tricarbaldehyde. It will have 1, 2, 4 tricarbaldehyde. Is it making sense? Right. This is one important form that is asked in JEE mains. So remember how to write the aldehyde forms. Next. Ketone does not have that problem because ketone becomes a part of the ring itself. So ketone does not have that problem. But now notice keto plus aldehyde if you have, then how do we deal it? So for example, if you have a ketone here and an aldehyde here like this, then you will number from here 1, 2, 3, 4, 5. So this will become 4-oxo or keto. You can use any word. 4-oxo. This is pentane. Okay. Pentane 1-al. Okay, pentanal. Like this. If you have aldehyde here, suppose if you have a CHO group here and then double bond O here, aldehyde here, and another aldehyde here, just like the earlier situation. So we'll start with this numbering here. So 1, 2, 3, 4, 5, 6, 7. This is the way you will go. And on 5th position, we will write as oxo. So 5, we have oxo, and rest it is heptane, 1, 2, 6 tricarbaldehyde. Tricarbaldehyde. So that is a mix of how you write aldehydes and ketones together. Got it? When it comes to cyclic structure for ketones, you will notice that if you have a ketone double bond O, and now I have, let's say, OH group. So obviously OH does not have much preference. And here I have NH2 group like this. So numbering should still start from here. 1, 2, 3, 4, 5, 6. This is the correct numbering. And now on 4th position, we have amino. 5th position, I have hydroxo or hydroxy. And this is cyclohexane completely. 1, 3 dione. We'll write it as dione. Now this time we'll write it as dione. Clear, beta? Any doubt in these cases? So I think you should be able to write this. Same logic you have to apply for carboxylic acid as well. Okay. So in case if you have carboxylic acid, you can write it in a very, very similar way here also. Got it? So I'll give you a few examples. I want you to write it down. Okay, as many as you can. Wherever it is not coming across, I'll help you out. Okay, clear? Check if you got this correct. So numbering should start from here. 1, 2, 3, 4. Second position, there is a methyl group with a double bond. So that is called as methylene. So 2-methylene, and this is butane, okay, complete ene with 1,4 dioic acid. So this is going to be 1,4 dioic acid. Next here, if you notice, this is a cyanide. Cyanide is a main functional group. So you start from here. 1, 2, 3, 4, 5. Okay. So in that case, the naming should be, and second position we have bromo, correct. And then we have 1 to 5 here, which is cyanide part of it. So therefore we will write it as right. So what do we have here? So this is spent. So this is spent 4 ine, 4 ine, and one position we have nitrile. So notice that one nitrile. Now this is the important part. Since it is starting with N, should we remove that E? No, right? That E should be still there. So 4 ine, 1 nitrile. Okay. You should not use the word cyanide. Okay. Cyanide is not an IUPAC name. Nitrile is the IUPAC name. Done. Next. When it comes to esters, this is the important part. In the case of esters, the alkyl part which is present on oxygen, that should be written first. So therefore, you can see, right? So we will write this as methyl. So methyl, that is the first thing you should write. And see the numbering 1, 2, 3, 4. So methyl, then we have 3 bromo, correct? And 2 methyl, because you have to write it alphabetically also. Okay, so bromine should be written first, then methyl. And thereafter, you can notice 1, 2, 3, 4 makes it but, correct? So this is but 3 in, clear? 3 in and 1 O8, okay, butanoate, isn't it? So but O8. But now this time that E has to be deleted. So you should not be keeping this E anymore. So it should be simply 3N1O8. Check if you got that right. Next one. Here it is the same thing. 1, 2, 3, 4, 5. So it is ethyl. You should start with ethyl because this is the right part which you have to write first show. So it is ethyl. Got it? So after ethyl, got it? So what do we have? Left, you can notice that we have pent. So this, sorry, we have substitutes after ethyl. We have substituted third position, so which is cyclopropyl. So 3 cyclopropyl. Then we have pent 4 in, only N, and 1 O8. Got it? 1 is not necessary. We can simply write it as O8 also. But we have to mention that only N, En. Next. Amine, when you have amines, check out for the longest chain first. So 3 carbon is the longest chain. So when you will write it as N comma N diethyl, okay, propane amine, propane amine. But at this position, we also have a substitute. What is that? 1 bromo. So we write it as that. 1 bromo, N comma N dimethyl propane amine. Next here, this is amide. In the case of amide, numbering will go like this. And on the left hand side, you can have this entire thing. I can write it as a tert butyl. 1, 2, 3, 4. So this is tert butyl. So I can write it as N tert butyl, N tert butyl. And before that, you know, you can see we have at two position, we have methyl and methyl. So 2 comma 2, acha, that should be written first. So we will have this as 2 comma 2 dimethyl N tert butyl. After that we have uh this is what, propan amide. Now this time the wording is amide. And last thing, numbering should start from here. Sulfonic acid is the highest priority. So on sixth position we have chloro, right? And this is cyclohex 2 in, complete in you have to write 2 in, then sulfonic acid, 2 in sulfonic acid. Done. So please check if you have got them right.